So, Jai Hind all. My name is Arun Kumar Maurya, Assistant Professor in the Department of Electrical and Electronics Engineering. So, the subject is Power System 1. The AKTU code is KEE 501. Under this lecture series, the first lecture was on Kelvin law and its modification to the Kelvin law. So today I will discuss the single line diagram, that is one line diagram, and the different types of conductors used for the power system applications. So as far as the content is considered, the first topic is SLD, that is single line diagram. Second one is conductors. We may see the different types of conductors, AAC, triple AC, ACR, and that's all. And their conductor materials and standard conductors and the types of conductors. So first of all, we may see the one line diagram and what is it and what is the meaning of SLD, that is single line diagram. So single line diagram is the representation of a power system using the simple symbolic of each components and the apparatus used for the transmission, distribution, and the generation part. So we all know that there are the three major components and the three sectors in which the power system deals. First one is generation, second one is transmissions, third one is distribution. So in single line diagram, that is one line diagram, is the network which shows the main connections and arrangement of the system components along with their data such as input, output, voltage, resistance, inductance, capacitance, and all the specifications of the electrical equipments. So we will see the structure of SLD, that is single line diagram. So we may see the typical layout of single line representation of typical power system. So this one is generator and these are the lines, and this is a transformer, and this side is load side. So this is source side and this is the load side. When we will discuss about the fault, when we will see the diagnosis point of view in the power system, we can easily measure the input and output side power, voltage, and the other ratings of electrical equipments, which we will see. So if we talk about the advantage of it, so single line diagram helps identify when to perform troubleshooting and simplifies the troubleshooting process. It is accurate single line diagram will further ensure to safety of the personal work. It meets compliances with applicable regulations and the standards, and it also ensures a safer and more reliable operation of the facility which are existing in the power system network. So I have discussed that we will see the conductor. So the important factors taken into the consideration while we select the suitable conductor. So these are the some specified parameters based on which we may choose a suitable conductor depending upon the application point of view in the power system. So first one is conductivity, second one is tensile strength, fatigue strength, coronal loss, local conditions, and the cost of the conductors. So if we talk about the materials of the conductor used, so first one is aluminum. We we may use, and the other one is copper. It is widely used in our application, all we know that. So if we see the comparison and the advantage of both the conductor materials, we may easily see the aluminum is cheaper, lighter than copper, good availability, handling, easy transportation, and air action. If we talk about the copper side, its tensile strength is high, high conductivity, more resistance to atmosphere corrosion. So the first one is standard conductors. So these are very much popular in a electrical power system network for the transmission and the distribution side. A standard conductor is consist of several thin wires of a small cross-sectional area called strands, as shown in the figure. So these are the strands. These are the small cross-sectional area, and we easily see the structure. There are some facts to be noted about standard conductors, and it is having sufficient flexibility which makes it suitable to the collide easily to transport it over long distances, over long transmission line also. For a standard conductor of same cross-sectional area, the flexibility of the conductor increases with increase the number of standards in the conductor. It's an important point. And the other point is the standard conductor is formed by twisting the strands together in the layers. The standard conductors of each layer are laid in a helical function over the preceding layer. This process is called standing. That's why it is called standard conductors. Generally, in successive layer, the stranding is done in the opposite direction to the preceding layer. This means if the standards of one layer are twisted in clockwise direction, the standards of next layer will be twisted in the anti-clockwise direction. So on X is number of the layer in the conductor. The last point is very critical and the important point to see the basic speciality of these conductors and the layers. There are some facts to be noted about the standard conductors. Generally, the total number of standards in any conductor is given by the formula, that is a simple mathematical formula. The total number of conductors is to be computed as n equal to 3x square minus 3x plus 1, where n is the number of standards in standard conductor. Generally, the diameter of conductor can be calculated by using this formula, capital D equal to 2x minus 1 into D, where capital D is the dia of conductor, where small d is the diameter of each standard. This is the comparative and comprehensive representation of the number of strands and the conductors based on the number of layers. So if I take the number of layer is 1, so n equal to 3x square minus 3x plus 1, so it is come out to be 1, and the diameter d equal to 2x minus 1 into d, which is d. So the cross sectional view of standard conductor is like 1, and if we take the number of layer is 2, so the n it's come out to be 7. So the diameter of conductor, which is capital D, equal to 3d. So the view of like is, and if we take the number of layers as a 3, so capital N, that is the total number of standards, comes to be 19, and that same diameter is come out to be 5d. And if we take the 4, total number of standard conductors available in this shape is 37, and the dia is 7d. So we will talk about the types of conductors. So first one is AAC, that is capital A and C, that is all aluminum conductor. So AAC contains one or more aluminum alloy strands, which is preferred for short spans. Usually in urban areas, we may use the all aluminum conductors. Uh, in the coastal areas, double AC conductors are also effective against the corrosion. It's a important thing. It's a corrosion problem, so we may use the AAC conductors in these areas, that is coastal areas. AAC has the highest conductivity to the weight but has a poor standard to weight ratio. It's a important specified parameter in this AAC conductors. It has the highest conductivity to the weight but has a poor strength to weight ratio. Other one is triple AC, all aluminum alloy conductors. It's an alloy conductor that is made up of aluminum, silicon, and the magnesium. Its ampacity is equivalent to the uh, double AC, which I have shown in a previous slide, and the possesses excellent tension characteristics. Triple AC provides excellent resistance against corrosion and used in the coastal areas like that AAC. Triple AC are becoming more popular than ACSR for the last 2 decades based on the research and the application point of view. They are stronger, lighter, and the more conductive than ACSR. However, they are more expensive than ACSR. In double ACSR, all aluminum alloy conductors steel reinforced. This is the another category of the types of conductors. This is formed by several wires of aluminum alloy and galvanized steel standard in the concentric layers. In this, the wire or wires which form the core are made up of galvanized steel, and the external layers or layers are made up of aluminum alloy. In ACSR, this is the another category, aluminum conductor steel reinforced. That diagram is like that. And aluminum conductor steel reinforced cable is a type of high capacity, high strength conductor typically used in the overhead power system lines. The outer standard is high purity aluminum, chosen for its good conductivity, low weight, low cost, and resistant to corrosion and decent mechanical stress resistance. In this, conductors combine the lightweight and the good conductivity of aluminum with tensile strength and rigidness of the steel. In this line design, this can provide higher tension, less sag, and longer span lengths than optimal with most other types of overhead conductors. I have seen, you may see the term is sag. So this is the part of our next unit. So I will discuss in the detail what is sag, what is catenary curve, and what are the parameters, formulas, and how to remove it, and how we manage the sag when we see in the power system network.